Good morning, friends. Already we completed chapter 9. Now, the some questions or the some numerical past asked in board exam. We are considering this because to clear a concept about the ray optics. Now, one example is that a swimmer is diving in a swimming pool vertically down with a speed of 2 meters per second. What will be the velocity as seen by a stationary fish at bottom of a pool just right below the diver? Effect index of water is 1.33. Here no other information are given, only the effect index of water is given, and the speed of a diver diving in a swimming pool is only given, there is a 2 meters per second. Now we have to find out what are the velocity experienced by the fish already that is stationary inside the water, that means inside a pool. For that purpose, just we do our diagram, what it suggests that. So there is the swimming pool. Stationary fish is inside the water. Here we consider the stationary fish is at here. Actually, fish is our observer. That is in denser medium N2 is equal to 1.33. Now the diver is in A medium. Okay. Now in air optics we have no any relation related to the velocity of object and image. Okay. For that purpose here the velocity of a diver is 2 meters per second. Therefore the diver travel a distance 2 meters in 1 second. Therefore, we consider the 2 meter vertical distance as A and B. That is the A and that is the B point. That is our 2 meter distance. That is our 2 meter distance. Okay. Now, by using the virtual height and real height, or the real height and apparent height, using this concept, here the height of A is HO. Height of A is HO and the height of B is HO dash. HO dash is equal to HO plus 2 meters. Corresponding to these two height, we find out the apparent height of this. Therefore, the distance of these two apparent height is the speed or the image of AB. And that is our speed of the diver experienced by the fish. Here the diver is in A medium, A1 is equal to 1 for AB. For that purpose here, consider like this in figure, the vertical distance of 2 meters is considered as AB. In figure, a vertical distance of 2 meters is and height of A from surface of the water is HO, and apparent height is HI. Therefore, HI upon HO is equal to N denser to the N rare medium, and our equation is that N observer to the N object. Now, HI upon HO, N denser 1.33 upon 1. Therefore, HI is equal to HO into 1.33, equation 1. Equation 1. Now, the height of B the height of B from surface of the water is HO' is equal to HO plus 2 meter. This HO plus distance between the A and B, that is the height of the pure surface of the water, and its apparent height is HI dash, therefore HI dash upon HO dash is again n denser to the n medium is equal to n observer to the n object. Clear this? Okay. Now n observer 1.33 and object is 1. Therefore, HI dash is equal to HO dash into 1.33. But the HO dash is HO plus 2 into 1.33. Therefore, 1.33 HO plus 2.66 HI dash is equation 2. Therefore, the distance between the A and B, or therefore the velocity seen by Fs is equal to the Hi dash minus Hi. Hi dash is this 1.33 HO plus 2.66 minus 1.33 HO. So that is cancelled. Therefore, 2.66 meter per second. That is the speed of a diver experienced by the fish in a swimming pool. Clear this? Very easy by using this concept of the real height and apparent height. But we has the concept like this: as we obtain the image of point A and point B respectively, the distance between this image, that means the A dash and B dash, that is the height of, the velocity of a swimmer experienced by the fish. Okay. Okay, now the next numerical second. Here, for a prism, we have to find out the angle of incidence and angle of emergence in two conditions. One is the minimum deviation condition, and second is for maximum deviation. Already we discussed about that. What is the deviation? The angle made by the original direction of incident ray to the direction of emergent ray. So that is known as the angle of deviation. In which case that becomes the minimum. Already we know that if the I is equal to E, that means the angle of incidence is equal to angle of emergence. In that case, the deviation becomes minimum. Deviation becomes minimum. Here the question is given for a prism. Angle of prism is 60 degree and the effective index of material of the prism is 1.5. Find the angle of incidence corresponding to minimum deviation and the angle of emergence for maximum deviation. Okay, first we do the diagram like this way. The prism is equilateral. So there is the normal view on one surface AB. There is the A, B and C. That is the second normal on surface AC. That is the incident ray PQ. Is the incident ray incident on surface AB at point Q. So that is the reflected in denser medium as QR. This QR ray again incident at point R on AC surface and emerges out as a ray RS. So angle made by immersion ray with the normal is E. That is the angle of incidence I. That is the angle of refraction R1, and that is also the R2. Now, if we extend this incident ray like this manner, so there is the PQE, and this immersion ray is extended in back direction. So both meet at point B. So this angle is delta. So there is our already learned in theory we have the relation I plus C is equal to A plus delta, and also we obtain the R1 plus R2 is equal to angle A. Now for first we have to find out angle of incidence I for delta is equal to delta minimum or the D minimum. Right? Deviation becomes the D minimum. Okay. Now for minimum deviation, what's happened? I1 becomes the I2. That means the reflected AQ are parallel to the base BC. Therefore, A is equal to I1 plus I2. That is our 2I1. Therefore, I1 is equal to A by 2. A is already given 60 by 2. That means the 30 degree. Thus, I1 is found. I1 is found, they require this I. So how do you obtain it? By using Snell's law. Applying Snell's law. At P, also here Q point. Now here the effect index N1 is equal to 1 for A medium. Here N2 is equal to N is equal to 1.5. For the glass medium, again here N1 is equal to 1 for A medium. So we are applying the Snell's N1 sin I is equal to N2 sin I1. N1 sin I is equal to N2 sin I1. Now result N1 is equal to 1 sin I is equal to N2. N2 is 1.5 sin I1. I1 that means the 30 degree. Sin 30 1 by 2. Sin 30 is 1 by 2. So 1.5 into 1 by 2 sin I. Therefore, sin I is equal to 0.75. Corresponding to that, find out the I. Approximate the 41 degree something. 41 degree and something mean for minimum angle of incidence. So this way we can find out the angle of incidence I for this. Okay, now thus we obtain the value of angle of incidence is 48 degree 35. So how we obtain this value? In natural sine, for which angle? This value is obtained 0.75. That means the 48 degree and 35 minutes. Okay, now in the second part, we have to find out the angle of convergence for maximum deviation. Now listen, for maximum deviation, angle of incidence I is 90. I is 90. If the ray incident at point Q at 90 degree angle, at the time the deviation becomes the maximum. Right? Therefore, applying Snell's law at Q. Therefore, N1 sin I is equal to N2 sin. I1 into sin I1. N1 is equal to 1 sin 90 sin 90 into 1.5 sin I1. So sin 91, therefore sin I1 is equal to 1 by 1.5. That means the 2 by 2.666. Okay. Therefore, value of the R1 from the directly see from natural sine. So its value is obtained 41 degree 48 minute. 41 degree 48 minute. So thus the R1 is obtained, the required value. Now we have relation A is equal to R1 plus R2. We obtain the value of R2, and again we have to apply the Snell's law at point R to obtain the E. Again, here for maximum deviation out of this point R, only the I is known, I is 90. Applying the Snell's law at point Q, I consider 90, R1 we obtain. After the R1 obtained, R1 plus R2 is equal to A. Therefore, we obtain the value of R1. After getting the value of R2, apply the Snell's law at point R, we obtain the E. Now, A is equal to R1 plus R2. Therefore, R2 is equal to A minus R1. 60 minus R1. R1 is our 41 degree 48. How we subtract this value? How we subtract this value? For that purpose here, actually the 60 degree is given. So here 60 degree we can add in that form. 59 degree 60 minute. Subtract here 41 degree 48 minute. So here 12 minutes. Now 8 and 1. 18 degree 12 minutes. There is the value of R2. Therefore R2 is equal to 18 degree 12 minutes. Now applying Snell's law. Applying Snell's law at point R. This one. Now N1 sin E is equal to N2 sin R2. N1 sin E is equal to N2 sin R2. N1 is 1 sin E is equal to N2 1.5 sin 18 degree 12 minute. 18 degree 12. So 1.5 to this value in natural sine 18 degree and 12 minute is value, and multiplication with the 1.5 is 0.4685. And natural sine corresponding to this value we obtain the value of E is 27 degree 56 minute. 27 degree and 56 minute. So this is the value of angle of emergence when the maximum deviation occurs. Maximum deviation occurs. Okay, now the next numerical. Real image obtained by a concave mirror is 4 times bigger than the object. Now, if the object is displaced 3 centimeters away from the mirror, the image size becomes the 3 times of the object size. Find the focal length of a concave mirror. Now, the magnification, right? The magnification of the image M is given, that is the -4. Why the negative? Because there is the concave mirror is given. The new magnification of image is m dash is equal to minus 3 times of the object size. That means as the object is moving away, so magnification is reduced. We have to find out the focal length. Focal length f we require. Now for that purpose we are using the mere formula. From mere formula, one upon f is equal to 1 upon u plus 1 upon v multiplied by u, Why we multiply by u? Because here the magnification is given m is equal to v by u. Therefore multiplying by u. Therefore u upon f is equal to 1 plus u upon. Now there is a first equation, or we substitute the u by v as 1 upon m. Therefore u upon f is equal to 1 plus 1 upon m, because the m is equal to v upon. There is a equation number 1. Okay. For object distance is u, m is equal to minus 4. Therefore u upon m is equal to 1 minus 1 by 4. Therefore 3 by 4, equation 2. So thus we obtain the value of u upon f. Now object is moved by 3 centimeter. Therefore new distance u dash is equal to u plus 3. The magnification is m dash is equal to minus 3. So from equation 1 is this: u upon f is equal to 1 plus 1 upon m. So this equation is 4. If the object distance is u, magnification is m. Now the object distance is u dash. So u dash upon f. At that time, the magnification is m dash. So 1 plus 1 upon m dash. 1 plus 1 upon m dash. Clear? Now we substitute the value. So that is the u plus 3 upon f is equal to 1 minus 1 upon m dash 3. M dash is 3. So it's equal to 2 by 3. Here this side u upon f plus 3 by f is equal to 2 by 3. Therefore 3 by f is equal to 2 by 3 minus u upon f. From equation to value of u upon f, substitute equation 2. Therefore 3 by f is equal to 2 by 3 minus 3 by 4. So 12 is the LCM. 12 is the LCM. So here 8 minus 9. 8 minus 3 by. So it's equal to. So minus 1 by 12, 3 upon f. Therefore f is equal to minus 36 centimeter. This is the focal length of a concave. So very easy, numerical. Using the mere formula, we can find out the focal length of a concave mirror. Here only the information about the magnification is given, initial stage and whatever the new stage. That means after object is moving by the 3 centimeter, what about the magnification? So we can find out the focal length of a concave. Okay, now next extra numerical. What is this step of the numerical we calculate in exercise? Now first we read the question, so you know it, this numerical written, I think. An equilateral prism is kept in a medium, and for a particular ray, the angle of minimum deviation is obtained, that is the 38 degree. And if the prism is immersed in water, there is in a medium. When the prism is a medium, at that time the light is incident at a particular angle I. At that time the minimum deviation is obtained 38 degree. Now this combination is immersed in water, the same light, same angle of incidence. At that time we have to find out the angle of minimum deviation in water medium. The effect index of water is 1.33. So how we can calculate it? So here we are using the equation of the effect index of material of a prism with respect to the A medium is equal to sin A plus delta M by 2 upon sin A by 2. Therefore, for A medium, Ng upon Na is equal to sin A plus dm by 2 upon sin A by 2. Na for A, effect index Na is equal to 1. A is equal to 60 and dm is given as the 38 degree. Substitute here, therefore Ng is equal to sin A 60 plus 38 by 2 upon sin 60 by 2. Sin 60 by 2. Therefore, so sin 30 and here sin 98 by 2, sin 49 upon sin 30. Therefore, Ng is equal to sin 31 by 2, therefore 2 into sin 49. Sin 49. Therefore, effective index of glass material is 1.509. 1.50. So when the prism is in a medium, at that time we find out the effective index of material of a prism. Now second, in water medium, A is equal to 60. Ng is 1.509. Nw for water is given 1.33. Require the dm dash. Same question, but here instead of the A medium, that is the water medium. Therefore, Ng upon Nw is equal to sin A plus dm dash upon 2 upon sin A by 2. Now Ng is given 1.509 divided by 1.33 is equal to sin A 60 plus dm dash by 2 upon sin 30. Sin 30 multiplied to the 0.5. Therefore, sin 60 plus dm dash by 2 is equal to 0.5 into 1.509 upon 1.33. So thus we obtain the value of this is 60 plus dm ds by 2 is equal to 34 degree 36 minute. Now simplifying this, we obtain the dm ds is equal to 9 degree 12. Find out yourself by using the substitute the particular value. So this way we can find out the minimum deviation and also the effective index of material of a glass. Whereas polarity step of the numerical we calculate is quite different in numerical value.